Very good morning, dear students. In this class, we are going to discuss about the failure, error, fault, and defect. Already in the last semester, we have discussed and we know the difference between the failure, error, fault, and defect. Failure is said to occur whenever the external behavior of a system does not conform to the prescribed in the system specification. Failure is said to occur whenever the external behavior of a system does not conform to that prescribed in the system specification. Error. An error is a state of the system. An error state could lead to a failure in the absence of any corrective action by the system. For example, we observe that the railway track, it is in under compliant, it is the state of error. If we are not correcting the railway track line, what happens? The possibility of the train accident is the example of the failure. So error state leads to the failure of the train. So similarly, if we are not in time correct the program error, it leads to the system failure. Fault is the adjudged cause of an error. Defect, it's a synonymous of fault. Okay, next one, the notion of software reliability. It is software reliability. We know that reliable is the performance measure or the quality factor. It is defined as the probability of failure-free operation of a software system. Failure-free operation is reliable, specified time in a specified environment. It can be estimated via random testing. Test data must be drawn from the input distribution to closely resemble the future uses of the system. Future usage pattern of a system is described in a form called operational profile. Actually, in that we focus the objectives of the testing. So whatever the main objectives of the testing is, it does work. Whether it is working or not, it does not work. Reduce the risk of failures, reduce the cost of testing. What is test case? Test case is a simple pair of input expected outcome. We know that in the previous semester we already discussed about the test case. In the connection of the testing, we are deriving or writing the test cases. The input is checking about the actual outcome and expected outcome. If the expected outcome is the same as the actual outcome, we can consider as the system is working perfectly. Stateless system. A compiler is a stateless system. Test cases are very simple. Outcome depends solely in the current input. State oriented. ATM is a state oriented system. Test cases are not that simple. A test case may consist of a sequence of input, expected, outcome. The outcome depends both on the current state of the system and current input. ATM example, check balance and whatever the amount, withdraw amount and whatever the remaining amount, $200, check balance. These are the queries. Expected outcome. An outcome of program execution may include value produced by the program, state change, a sequence of values which must be interpreted together for the outcome to be valid. A test oracle is a mechanism that verifies the correctness of a program outputs, generated expected results for the test inputs. Compare the expected results with the actual results of the executing the IUT. The concept of complete testing or exhaustive testing means there are no undisclosed faults at the end of test phase. There are no errors. There is every phase or every error will be checked out. Complete testing is near impossible for most of the systems. The domain of possible inputs of a program is too large. Valid inputs, invalid inputs we can categorize. The design issues may be too complex to completely test. It may not be possible to create all possible execution environment of the system. The central issue in testing, we observe that input domain is represented with the D, and whatever the two areas D1, D2 is the subset of the domain, and program is denoted by the P, and P1, P2 are the subsets of the program P, and we are taking inputs from the input domain D and apply inputs into the program P and observe actual outcomes. A subset of the input domain exercising a subset of the program behavior is the diagrammatic presentation. Divide the input domain D into D1 and D2. Select a subset D1 of D2 test program P. It is possible that D1 exercise only a part of P1 of P. Okay. Testing activities. Compute, execute outcome for the selected inputs. Testing activities, actually the pre-program environment and observe actual outcome. Selected input is encoded or whatever the given to that of the program, and observe actual output, and the result is analyzed whether the outcome is actual outcome or not. Assign a test verdict whether it is right or wrong. Compute expected outcome for the select input. Identify the objective to be tested. Select inputs. Compute the expected outcome. Set up the execution environment of the program. Execute the program. Analyze the test results. Testing level, we already represent, that is the V model. We saw it in the UC level, whatever the process models, and here also we revise again. Development and testing phases in the V model, we observe that unit, integration, system and acceptance testing. In the unit testing, we checked the coding, and the integration testing, it is the detailed design, and system testing, high level design, and the acceptance testing is the requirements testing. Unit testing, integration testing, system testing, acceptance testings are the 4 levels of the testing. Unit testing, what we are going to do is the individual program units such as procedures, methods in isolation. Integration testing, we are dividing the modules. So modules are assembled to construct larger subsystems and tested. System testing includes wide spectrum of testing such as functionality and load. Acceptance testing, we know that the relation of the customer's expectations from the system. 2 types of acceptance testings, UAT and BAT. UAT, system satisfies the contractual acceptance criteria. So user acceptance criteria. System will eventually pass the user acceptance test. Testing level, so again whatever the 4 levels of testing, unit, integration testing, system testing, acceptance testing, again we observe that the regression testing. Regression testing at different software testing levels. No test cases are not designed. Tests are selected, prioritized and executed to ensure that nothing is broken in the new version of the software. Source of information for test selection, requirements and functional specifications, source code, input and output domain, operational profile, fault model, error guessing, fault seeding, mutation analysis. So by this we close this class and meet tomorrow. Thank you one and all.